We'll just kill that right there and go in and fix this. Why do these things happen? I don't know. There we go. We're back. So yes, last time we fixed some problems in our data. There's always problems in your data. That is just the way it's going to be. It's always going to be that way. And we tried to make a dopey model. I recall it did very poorly. I want to revisit that, and we tried to make a little model, little heuristic model, based on the sort of mean, what does a 3 tend to look like as an average versus a 1 versus other things, and how closely correlated are all those. So I'd like to revisit that. I recall there were still some problems. To be honest, I have not looked at this in a week, so I may not remember all the details that I need to do. But let's give this a whirl. Let's read in our modules. Oh no. You mean OS is not? Oh. Really? Huh. Apparently I never imported OS. That's highly... Oh no. This is going to do terrible things. No! Stop, 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 stop. Kill it. Kill it, Dad. Kill it with fire. Okay, much better. Yes, bad things can happen to my TensorFlow if I don't load it very carefully with these kind of operations. I've noticed this is very common. TensorFlow, like so many other machine learning libraries, Jenga tower dependencies. Next project, I'm definitely going to try PyTorch. I think that'll be interesting. I hear good things about it. I would love to have that and say, oh yeah, that's working real great. That's exactly what I want. Okay, we loaded in the basics. I'm going to skip this model bit here, and I want to read in some of this data. Train is not defined. Oh, there, well, let's load it in. Okay. Again, this is what the average 0 looks like. Again, I don't know what's going on there. It is what it is. If you wanted to see what the average 1 looks like, look at this, that's a 1, you see this. Some people do verticals, some people do slanted that way. Different styles for different folks. Now what we're doing here is for every digit, we want to compute the mean over that digit across all the images. And, oh, I'm showing these off in the in a little subplots display, because that's cool. That almost worked. Almost. Almost. X is not defined. That's a lie. Oh, I know what happened. I know what happened. I'm going to turn off auto indentation, because I use SlimeMux. I don't need your fancy auto indentation. I supply it myself. So you get 0s, 1s, 2s, 3s, 4s, 5s, so on and so forth. Obviously nothing here, nothing there. Could have gotten fancy and fixed that, but this is just way easier. Okay, so those are our mean arrays. We now have axes is a thing. Oh, axes is a... No, it's not a list. What? Oh, that's not what I want. M. M is what I want. Yes. 10 things that are 28 by 28. That's what we want. Yes. Then... we got some more data. What is this? Oh, is this the data I'm loading? Hang on. Do I load my own data? I do. Right, I got TIM. Not shape. That's not shape. Well, yeah. These are our initial images, of course. We don't actually look at any of those, do we? Huh. Well, we can look at one. Plot.meetshow of TIM of 0. Meet show, not mate how. Doink. Right, this is a 4 and 2, pretty clearly. Right, there's a 4, there's the 2. It looks pretty obvious to me what's going on. Whoa, yeah, even bigger. Meant to click close. Training labels is the other part. Yeah, we can. What is it called? T-lab. Not enough values to unpack. Expected 2, got 1. Oh, I don't want to plot that. I just wanted to look at that. Right? That's the problem there. Doink. As you see, it's a 2 and a 4. 0, 1, 2, 3, 4. So human being, no problem. We were able to identify that. Super easy. But let's see if we can do that with like this heuristic model. I do want to try and get this heuristic model working today. That is the goal. That was the goal last week, but it's the goal this week too. We'll keep doing it until we get it right, or it just seems like it's not worth it. So maybe if it doesn't work out this week, I'll say screw it. We'll do the machine learning thing. Maybe we'll make some other heuristic. I don't know. And again, I know that all these are limited to 2, a mix of 2 numbers, but our model doesn't really know anything about that. Particularly the machine learning model doesn't know anything about that. There's ways we could encode that, I'm sure. For now, we're just going to have it predict sort of 10, is it this or not? Is it this or not? Is it this or not? Tags, so to speak. All right, now what is actually going on here? This is for all of my input data. This is A. I have to remember what this code is about, right? Alright, I make a bunch of zeros. And they, for every pair of digits, right? Can I have something that occurs twice, though, in my data set? Hang on. Let's take a look at that data. T lab. Axis equals 0? No, 1. Right, okay. Let me take the set of all those. Yes. So I always have 2. I never have something. I always pick 2 different values. So boom. For I in range 10, for j in range whatever the other number is. Who cares? Not I though, so don't start at I. Maybe that was part of my problem here. Probably. I'm looking at the means of all of my image data minus the mean of the first one minus the mean of the second one. Hang on. Let's look at that. And let me do that. Right? That says A of all entries. Right, because this is, but I'm taking the mean here. Nice. I'm seeing some issues here, right? Trying to remember what it is we're doing. Let's get rid of the mean here. Let's just look at this for a second. Just for a second, right? What is the shape of this? Right, this is every single piece of data, sort of minus this other thing. Minus a 0, minus a 1. That's what they all look like, right? So, if you wanted to, you could look at the first one. That's a 28 by 28 thing, you know? You could plot that, match show that. Yeah, that's that 0 and you can still see the 4 and the 2, but like some kind of 0 is in here and some kind of 1 has been removed. So actually, if I got rid of a 2 and a 4, what does it look like then? How interesting is that? It's, the 4 is kind of wiped out. This 2 is definitely still here. This is a big fancy 2. Yes, those are float 32s. But is T, what is TIM.D type? Important to look at the D types. That's U and 8. What is M.D type? Float 32, okay. Because if you say, well, look at my first image, whatever it is, and I subtract, I don't know, 128. Those aren't negative numbers. Those are a bunch of zeros minus 128. Rolls over, so do be careful. But if I say, I don't know, 128 times numpy.1s, excuse me. Actually, I said minus 128 dot. What does it do then? Yeah, then it does it correct, you see. It converts everything over to a float and everything's fine. So that's why we needed to do that. Why was I taking the mean though? That's what I'm trying to figure out. Why would I have done that? Let's not do that. Right? Let's not take the mean. That seems a little silly. Let's do this then. This takes a little bit of time, as I recall. Could not broadcast from whatever to whatever. Well, boo-hoo. That's curious. Really? Oh, hang on. That's 28, 28. A dot shape. So I don't want Hang on. I just took the mean along the wrong axis. Ew. I don't want to take the mean over all these guys. I want to take the mean over all the pixels. Right, that's what I want. I have to make mean along specified axis. Axis or axes along which means you're computed. Okay. So, we've got this little array. AA equals this thing. Like, right. So this is every single object minus a bunch of stuff. What we want to do is I want to end up with just 65536 numbers. Just that many. So I want to, yes, over these two axes, take the mean. So why did that not work? That is exactly what existed there. Sure. Unless I'd like just fixed it. Oh, jeez, oh man. Come on. It has to be tuples. That looks like it'd be correct. Alright, let's restore exactly what I got rid of. Maybe I just fixed that at the end of last week's episode. And I, of course, did not, you know, remember that. Axes. Axis? Axes? Axis, I think it's called. Equals 1, 2. So those last two. Do that. Let's have this happen, shall we? Takes a little bit of time. But gets faster and faster. Okay, so now we have 2 to the 16 of these things. So for every single image, so I can do plot.meetShow, for example, a of 0. Yeah, so that's sort of right. So one would hope that the combination of 2 and 4 would be a particularly small number in this case, or close to 0? Close to 0 is what I want, yes. Yeah, of course the identities are 0 just because we're ignoring those. But yes, you'll notice this upper triangle, same as the lower triangle, because ij equals ji, so that's all hunky-dory. This is super strange to me, that the whole column with 1s is just differently colored. And I wonder how true that is over the whole image. Actually, what I want is, do I have my DVB library? Is that a thing I have? No. What I want is my big yellow duck. A friend of mine wrote a nice library. Big yellow duck. That has some really nice visualization tools in it. That would be exactly what I want in this situation. Tell you what, let's open that up then. Let's open up some Chromium and do some searching. Yeah, that big yellow duck would be really nice right now. Could have sworn I had it. Big yellow duck. GitHub. See if I can find it. There we go. Could have sworn this had a thing to do what I wanted. Maybe it doesn't. I'm looking for image SC. That's what I want. Yeah, so it does. Did I just not install this like I wanted? Maybe I did. Oh well. I will deal with that later. Although maybe I should. Maybe what I should do is Python image SC clone. Right? Clone an image. No. I want image SC, mate. Google. They try to be smart, but it just does not work. Oh, hey, image SC. Dink. That's exactly what I want. Python package to create heat maps, works in Python 3, yada 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 yada, fast and clean. Oh, LC burn. Oh, that's cool. Yeah, let's try that. Let me just go pip install image SC. Let's see how that goes. I haven't actually used this specific version of the library, but we'll see how it goes. Could not install, blah, 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 permission denied. Yeah, we're going to sudo that. That's all we're going to do there. Take care of that problem. Cannot import name main. That's cute. I got a pip update, I guess. Jeez, man. Pip update. Install pip. Pip install dash upgrade pip. Sure. That's probably what the problem is. Zoom! Look at all that stuff. Alright. Sudo do that. Sudo do this. Really? So my pip is broken. Yeah. We're gonna history rep pip. Really? I have to do this horrible nonsense? Clearly I've done some other pip stuff, but it doesn't want to work right now, and I used to just be able to do pip. Fine. Pip install dash user, even though I'm, root on this machine, doesn't matter. We'll just do this. That should be fine. You're using pip version, whatever, don't care. Do not care right now. Okay. Import image.sc. No package name packaging. Gosh, why wasn't that in the dependency list? One of these days. Packaging. Right? Is that good now? Successfully installed. Okay. Okay, there we go. Just a little silly. Image.sc dot. What are the things you can do? Fast, clean. What? Fast? I don't know. Quick start. Boom. I want to be able to look at, scan through the heat maps that I just generated very quickly. Quick start. Quick start. Quick start doesn't actually work? Yeah, okay. Quick start is not a quick start. Cute. It's based on Seaborn. I don't really care. Cluster fast. P color fast. I don't. Oh boy. Fine. What are my options? Let me just clean, fast. Yeah, let's just do fast. Fine. Just do fast. I don't really care. And A. Too many values in a pack. Expected 2. What? What do you mean expected 2? That's a lie. I want to be able to spam through my data. Apparently I can't do this. I'm asking for too much. Alright, what does fast actually take? Data, the data array, row labels. I don't care about row labels. I don't care about call labels. I don't care about any of that. That's nonsense. I'm going to directly use this input. Should be able to take a n by 2D array and show me one of them, and then I should be able to spam through them. But maybe I misunderstand. And of course all your images don't work. Clean, no grid. Limited configurations, ideal for photos. Sure, let's try clean. You got 5 different ways to do the same thing. Let's see if it works. No. Too many values don't pack. No. That is a lie. You are a liar. Wait, what if I do this? Mate, I want to be able to spam through to several at once. That's terrible. Why would I use this then? Speed. I don't want one. I want to be able to look at multiple images real quick. Maybe Seaborn is the one you want? And just like hit a button and go to the next one. Maybe. None of these are going to have useful information. Yeah. Must pass 2. At least that's a useful error. Alright, so that's useless. I was hoping image.sc would let me just look at the first one, look at the second one, the third one, so on and so forth. There's ways to animate your matplotlib heat maps, but it's a huge pain in the neck. And I don't want to do it. So what we'll do, since we have this now, oh yeah, we can look at this. This is kind of cool. This is the mean across all the data, which to me is kind of strange, because this number ones here are still very strange. And what I suspect the problem here is that the actual mean of 1, for whatever reason, it has much higher values than the other ones. Like the peak is like 256 or whatever. What if we look at, yeah, that's like a mean of this, and a standard deviation of this, and a maximum value of that. Whereas if you look at number 2, the max is much lower. 3, 4, 4 is getting up there. But that's of course because most of the ones are directly there. It's one of the least spread out numbers, but it's causing some problems in our data here, perhaps. You subtract the 1 from it, things start to look goofy, like it's not normalized, in a sense. I don't know, it's debatable whether we want to correct that or not in this case, because the 1s really are more intense, so you kind of want to keep that information around, but if this means you're going to predict everything as a 1, then you don't want to keep the information. You see the quandary. Alright, anyway, we got a bunch of A's. Got a bunch of things here. We want then the 2 highest values when we look at, for a given image, in our A, right? Our A array. And in fact, I should make a V array that is likewise. Let's do this. Change it to V for all of our validation data, right? There we go. And we will compute the same thing. V, except this is going to be BIM, yeah, and all this stuff goes the same. Perfect. Redo that. Take a little bit longer. Oh, come on. Oh, boy, oh, boy, oh, boy. Not broadcast from whatever nonsense I just did. Really? 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 That's not a... Oh. Missed one. There we go. So let me know. That's how it goes. Okay, that is running. What we want to do is make a simple heuristic. This is what I want to compare our machine learning model to. There's, I'm sure, better ways to make simple heuristics. We want to grab the 2 scores, 2 labels closest to 0 for a given image. Right? That's what we're going to say is correct. So the smallest one is easy to find. The next smallest one, we have to do slightly more work. So for a given image, right? Oh boy, yeah. This is a little bit goofy. We want to find the 2 smallest indices in this array, and really only the upper triangular part. Is there a way to say what does this do? An array with 1s at, no. I don't want to create a triangular array. I want to return only the triangular portion of the array. I guess I can use this as a mask, can't I? Of a.shape. Can I do that? Something I can do? A.shape of 1 to the end. Let's do 10 by 10 here. Right? Yeah, whatever, that's fine. I don't really care. No, hang on. But I don't want the... What is K? Subdiagonal at or below which the array is filled. K equals 0 is the main diagonal. Font is 0. So, -1. K equals -1. There we go. Get rid of the identity, because those are all by default 0. I know those aren't right. So, I think if I said, for example, a of 0, comma this, what happens here? No, I didn't think so. Oh, no, what I can do, hang on a second. I can take a times this. 0 out all this other nonsense. Oh, shoot, I don't want to 0. That's exactly what I don't want to do. I tell you. Zeroing out is the last thing I want to have happen. Oh, boy. Oh, bother. What am I trying to do? I'm trying to extract only like 1/2 of the array. And there's various ways we can make this work. Ultimately, this doesn't really matter. I thought it would be something good we could do, but maybe not so much. We'll instead just do take argmin of... Oh, but I do need to ban the EIIs, the IJs, all this other nonsense. So I'll tell you what. I do actually want that. What I want to do, take a, like, adjusted, right, equals numpy.copy of a. Right, we'll do that. And I'll say A adjusted equals A adjusted times this numpy.try business. 10, 10, k equals -1. Right? Do that. Right. In fact, what we'll do is we'll just do that over here. So it's all in place up there. Perfect. What we're gonna do, take A adjust, right? This big old thing. You're looking for 0. In fact, let's verify that we have the right thing. Plot dot make show. This guy. Boom, all zeros, perfect. And just another one just to verify. All zeros up there. Good. Good, 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 good. That's what we want to see. Then, I want to change all those guys that are 0 into some other number, any other number. I don't care. Like, I don't know, whatever the maximum of the array is. Just something so I don't select those. That's the important thing. So I want, wherever it's equal to 0, equals 0, equals 0, wherever that's true, I want to set the value to whatever the maximum of the, or the entire array. Just to make my life simpler. You could do it individually for each element. I don't actually care, because it's just, I'm not going to select those, so it doesn't matter. There's no reason to make my life a little harder. Boom. No, I should probably make this, boom. And now, if we do our plot.makeShow, this value is all 28.4, which is apparently the biggest number there is. Cool. And what I'm going to want is the number closest to 0. Actually, do I have a color bar? It'd be great if I did. Color bar. 0 is a greeny shape somewhere over here, maybe? No? No? None of this? All these other ones might be 0. But anyway, well, no. A positive one exists. It's 28.4. Cool. Okay. What will be the label, then, is the thing with the, not the minimum value, like the minimum absolute value is really what I want. What is closest. So also, A adjust is equal to the absolute value numpy.abs. Again, I do not care what the actual number is. I just want the two that are closest to 0 that says, yes, this is most likely to be correct. We can do a fancy correlate thing. This is just a real dumb thing, just so you could see what's going on. All right, we'll take the absolute value. Great. Now you plot the matrix. It's looking a lot bleaker. Right. Now you see 0. Ooh, 0's not even on this list for this particular one. But now you can just look at the minimum. You say, oh, hey, what's this thing? Okay, maybe a 1 and a 7 looks interesting. Or whatever these other things are. I mean, that's wrong, but that's what you're going to see. We'll see how good this model does. So, to get the minimum then, I want to take numpy.argmin, and we'll say, okay, numpy.argmin of A adjust, right? Axis equals, return indices minimum values along an axis. Index into the flattened array. It's only an int. I can only provide it along a specific axis. It's going to be trouble, because I need to provide it along 2 axes. Unravel index. Convert a flat index into an index tuple. Take along axis. From argument to an array. Whoa, what is going on here? Apply numpy to expand names from argument to array as if calling min. What are you talking about, fool? Axis equals 0. So you generate 3 numbers. Could you take the minimum of those two? Where's the minimum? Where's the minimum? Where's the minimum? That's odd, because the 0 axis, there's two things here. Axis equals 1. So across this axis, right. So I want it across the last two axes is what I want. Unravel index. Yeah, but I don't want... That's sort of what I want, right? Sort of what I want. That's a 0. Yeah, we got some fanciness with it. Argmin is the problem. I mean, you can take the minimum along one axis and then the minimum along the other axis, and you could... Hang on. No, that still doesn't work. Well, they should meet up somewhere. The absolute minimum will be the minimum in both axes. Right? So that's what's going on. Question in the chat, what model is this? This is a dumb heuristic model. Just build something to compare it to. As you can see, building your heuristic model often requires a lot of logic to figure out, like, well, what am I really computing? What's really going on? If you're building a machine learning model, you can often get away without doing that. Just define the inputs, define the outputs, get from A to B. You'll find you still have to do quite a bit of computation. Let me see, what kind of shape does this give me? You'll still have to do a fair amount of computation. So that gives me the minimum along every row. So in the first row, in the second row, in the third row, and so on and so forth. No, it's down the rows. Hang on. Yes. Across the rows. Ugh, boy. Let me look at more examples. And then we might decide that argument is not what we want. Not what we want at all. But there's a good vectorized way to do this. And I realize now it's already 6 o'clock, running out of time. I'm actually on Phoenix time, so when daylight savings changes, I will not change. Very nice. I don't have to worry about that. All of you have to worry about that. That's why my channel says Eastern Standard Time, not just Eastern Time or Eastern Daylight Time. So do keep in mind, the stream will, for some of you, be, I think, later. I don't even have to pay attention to this stuff anymore. I don't worry about it. I just, whatever time it is whatever time it is. Oh boy, oh boy, oh boy. Well, you know what? I'm going to have to do it along both axes at some point. Oh boy. So let me... Right. Do that. So I'm only looking at the first one. And I know the minimum there is this place. It is in row 7, column 1. 7, 1. Again, that's not what the right answer is, but that's what the model is saying. This, to me, it looks like this is giving me the right column. This is giving me the right row. I don't just want to take, I can't guarantee that the same row and column will always be in the mix-up there. The minimum, shouldn't there be one where, no, hang on. It's like I need a little whiteboard, but I can't show the whiteboard to explain my thought process. I need some GIMP action is what I need. Not this. GIMP. We got to do some drawing here. Yeah, whatever. Make a new thing. I don't care what it is. None of that matters. What we need is just like some pencil work. Right? Cool. If I have my actual array here, and I find the minimum in each row, we're trying to see if this is a thing that can even answer what we want, and a minimum in each column. We're doing, those are the two things we're doing. So I might find the minimum in this row, or the location of the minimum, and I might find, oh, it's the first one in this row. It's the second one here. It's the first one here. So on and so forth. And in here, this is in this column, this is telling me which row is the minimum. So I might say, oh, it's 0, it's 1, it's 2, it's so on and so forth. So sort of for each column, for each row I identify here, right, which row is the interesting one, or which column is the interesting one. In that column, I want to find the interesting row. Hang on. Whatever, oh geez. In the column I identify here, what row do I identify in the opposing guy? So in this one I say, oh, column 1 is interesting. Great. I need to find a particular column, and that needs to refer back to a row. If these refer to the same physical location, I'm running out of colors here. If these refer to the same place, then that's a win. That's a minimum along here and a minimum along here. Can this happen another way though? So this one says 2. Right, so this is in row 2, so okay, so column 2 is this one. For this column, however, we say that, oh, row 2 is interesting, 0, 1, so that'd be here. So those don't line up. If it's the absolute min, it will win in both. It must win in both. There could be ways, there will not be ways that it will win. Otherwise win, right? What if I have another pair that say, well, this thing is good? Because, you know, this guy says, okay, in this row, this value is the smallest, whatever, the smallest guy it is in this particular row. So no, it says 7. And over here then, it says, I don't know, whatever it is, maybe that's 7 again. Whatever it is, those two agree. Because you're only looking at this many objects, and so that's a min among these. Okay, so of the ones that agree on their position, you get a list. So you'll get some, hang on. Let's change to blue, teal. Get rid of that. You'll get a bunch of IJs. IJ1, you'll get another IJ2. You'll get at most 10. But not significantly more. You can say axis equals 0 or 1? Are you sure you can do that? That'd be pretty baller if you can. Let's try it. You can do that with minimum, but can you do that with argument? I would be blown away, because 0 or 1 is just 1. Right? In logical Python land. Yeah. Yeah, see, that doesn't give you the things you want. That's the same as doing axis equals 1. Same array. I think this is kind of what you have to do, unless you just want to scan through the whole thing, find the minimum in each, like call min on the unraveled indices, on each specific kind of guy. There's probably a way to do that, actually. Let me think about that. Unravel index. What does that mean? Convert a flat index or array of flat indices into a tuple of coordinate indices. Not exactly what I want. Not by that ravel. Return a contiguous flattened array. That's sort of like what I want. In unravel index, do I have to provide the shape? I do. Yeah, so this isn't exactly what I want. Like, I could run argmin each time for all the guys. Okay, here's what we'll do. I gotta do axis equals 1, I gotta do axis equals 0. Doesn't really, or not 1, 1 and 2, rather. I don't know, we'll call this the rows. Doesn't really matter. Call this the cols, right? So rows of 0, this guy, cols of 0. What is it that we want? So these are, hypothetically say, all the row indices This says like, oh yeah, row index 1 is definitely got my minimum. Well, look at row index 1. What do we say my minimum is? And this is in the first column. Well, here, row index 1 says, yeah, hey, take a look, pal. I get a 0 there. So that's a potential match. Row, it doesn't matter if I say row 1, column 0. None of that matters, right? I actually don't care what the value, well, I do care what the value is. I want to make sure not to get a 0 1. I want to make sure that my row is a larger number. Right, just the way I've oriented this, this object here. Okay, so this will, I could step through these and generate the list of potential matches for each guy. This is sounding painful though. This is sounding like maybe I do just want a for loop. Yeah, let's do the dumb for loop thing first actually. So for A in A adjusted, so for every single object here, right, I want numpy.argmin of A, right? Because if I said numpy.argmin of A adjusted of 0, right, I get 71. That's kind of irritating, right? Oh, because it computes it along the flattened, right. Unravel index, convert a flat index into an index, right. So you do this, but then you say numpy.unravel index. Unravel index, and it's going to be 10, 10. Yeah, and then you get 7 and 1. Of course, there's kind of obvious how that worked here. You can do this for every single object. I just wish that I could take the minimum along 2 things. Actually, let me check the internet. That we can't do that. By argmin along multiple axes. Yeah, along multiple axes. Other people have asked this question. Without a loop. Is there a way to do this? You do something like this. Reshape the array. Oh, that's an interesting idea. Reshape the array. Take your argmin, but when you do the unravel index, you just pretend you're in the original array. Okay, that's a good idea. Let's do that. That's the smart thing to do. Alright, screw this. So, once again, changing our mind. Say numpy.argmin of A adjust dot reshape. And what is the new shape going to be? It's going to be however long it is. Length of A adjust. Right, whatever, how long the first dimension is, I don't care. And then just give me the rest. I know it's 100, but comma axis equals 1. Okay, this will give me a bunch of mins, right? These are all our mins. They're always 71, which is kind of curious. Okay, no, there's a bunch of different numbers. Usually 71, because there's something about 7s and 1s that are kind of broken. So maybe I do need to go back and fix that. And this is just some overall bias. It's a little irritating. That's how it goes, though. Okay, those are our minimums, and you can read this off: 7 and 1, 7 and 1, 7 and 1, 7 and 1, so on and so forth. Unravel index. Can I do this over? I can't. Erg. That's annoying. I can't apply it over along an axis. Can I? Return, see also, ravel multi-index? Oh, what's that? Multi-index. Converts a tuple of index arrays into an array of flat indices. Applying boundary modes. A tuple of integer arrays, 1 array for each dimension. I don't think that's what I have. No, I don't think that's what I have at all. Either way, that's still not too shabby. We can do this a slightly different way, though. Min indexes is going to equal, we'll make a new array of zeros. We'll just compute it ourselves. We can do that easily in this case since it's a 10 by 10 array. So you'll just divide by 10, and you'll, however many factors, multiples of 10 you have is one number, the first number, and whatever the remainder is the second number. So So do divide by 10, integer divide, and do mod 10 as well. Keep your life pretty simple. 50 more minutes, I think we can get this done. And we can have a heuristic model. We can see how bad is it? The answer is probably pretty bad. Length of A adjust. I want a bunch of zeros, right? I want one. Length of V in, right? It's the same number there. Comma 2. I have 2 indices for each of these. I don't really care about the D type, that's not important to me. And what I want to say is that min index of everything, comma, the tens place, right? Or not the tens place, but the x values, so to speak, is equal to mins divided by 10. And the first one is equal to mins mod 10. All right, that's the efficient way to do this. Could not broad, of course. Of course. 8192. Oh, not V. No, T over here, right? T. There we go. Okay, and these are all my supposed, solutions. Yeah, we need to convert those to the one hot encoded or whatever. tf.keras.utils.one hot. No, I don't want one hot though. I want many hot. Yeah, hang on. How do I convert this back? Surely I did something like this. Alright, well, let's make a new array then. These are our predictions, so we'll call it the predicted array. The predictions are numpy.zeros of whatever the length of however many things we're dealing with, of course, as always, and 10. Right, 10 potential labels, and I will say that the predictions of all the things, comma, min indices, everything, comma, 0, equals 1, as well as everything, comma, 1. Actually, I think I can do that. Can I just say this? Let's find out. No, I didn't think so. Arrays must use as indices, must be of integer or Boolean type. Oh. Okay, that I can do. It just wants, nice little integers. Numpy dot, uint 8, whatever, who cares? That's not really important. Boom. That's taking its sweet time, though. That is taking a good, sweet chunk of time there. Am I eating up all my memory? No, I'm not. I'm eating up all my CPU. That's really not that complicated an operation. Oh, okay, I did finish. Good. That's not right. Nope. Nope, that's not right at all. Just made a whole bunch of ones there. Right. All the things, comma 0. Tell you what is pred? And let's reset pred, of course. Gotta do that. Pred of all the things, comma. Oh yeah, 7, comma 7. Not all the things, just show me the first 2. Right? Yeah, just to test a couple things. Do this. Can you extract a thing there? Interesting. I wanted 1 row, I got 2. Oh, because it showed me 2 things. So I did this, I just grab 1. So it doesn't apply it on a per row basis, which is kind of irritating. How did I do this before when I was making my data? I probably just made it on the fly, huh? Tab new, make data. Digits data. There we go. Make data, make data, make data. Labels blank, blank for I and choice. Yeah, I set it for a single one at a time is what I do. There's got to be a faster way to do this. Like a nice NumPy vectorized solution. That's always what I'm looking for. When you're dealing with a lot of Python, that can save you a lot of speed and do things correctly. If you're in a low-level language like C, it doesn't really matter as much. Write a for loop. It's just as fast as anything else. Because under the hood, somewhere there's a for loop. But if I can make the for loop in NumPy, under the hood without me thinking about it, that's much faster than a Python-based for loop. On the other hand, however, if one solution is working and the other one's not, well, maybe that tells you what your answer is here. So I need to mask off certain values. So there's always the, for row, for I in length pred. And I say pred of I of those two values min index of I equals 1. This is always the dumb thing you can do. You'll find that this is rather slow. Do I have TQDM? Import TQDM. I do. Ho ho ho. TQDM.TQDM of all this. Int object is not iterable of range. Fine. Fine. We'll do that. Arrays use this, these must be of integer. Great. Range, length, breadth. Of course, numpy.array, all this stuff. Because I didn't make it integer before, because I'm a terrible person. Numpy.uint8. There we go. Yeah, alright, well, it didn't take very long. Fine, we'll do this slowly. But it took a measurable amount of time. That's what's unfortunate, pred. And that's definitely the right thing there. So we should be able to predict some sort of accuracy. Import sklearn.metrics, metrics.accuracy. Oh, metrics just, no, sklearn.metrics. An accuracy score. In multi-label classification, computes a subset accuracy, blah, 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 much math exactly. Right, this is with the actual, like, integers, though. Sample set must exactly match the corresponding set of labels in Y true, which I'm sure is almost going to be none. Or label indicator array sparse matrix. I do not have a sparse matrix. It is a label indicator array, though. Because we got TLab, which looks like this. We got pred, which looks like this. Should be the same length. And again, which one's which? True first. Okay, perfect. So TLab, let's see what happens. Pred. Currently, getting 2% accuracy, just for reference. If, however, you will permit me a possibility. No, I don't want to import it as anything. There we go. Let's look at how many numbers we got right at all. Obviously, there's some dumb things going on here. The dumb model does much better than this. Let's keep this around. Dunk. But I want to also look at anywhere. If we got anything correct, anywhere we have a 1 here means we obviously got something correct. Now, we're guessing a whole lot of 1s and 7s, so you kind of hope for a 10 or 20% baseline in this situation. And I'm sure it's almost universally 1s and 7s in this situation. So what we can do is look at how many labels did we get correct here, divided by how many total things do we have. Length of T image. This is on training data too, so training data. There's no data here, of course. Yes, so that is considerably better. We much more often get at least 1 correct, essentially. Not that great. Some might even say, terrible, hot garbage. But yes, to get both correct Very challenging. I don't know what a human being would do in this situation, but to me that's an interesting number. That's also, it's also good to look at. Like, okay, yes, we are sometimes able to get one correct, a heck of a lot more often than we get both correct. We only get both correct very rarely. You can look at that actually. Hang on here. If I look at the sum, no, not the sum of this. If you're looking at this, and you take this along the columns, right? Ooh, not like this. There we go. So that's for every column. Like, did we get the, what is the sum over that given row, right? And I want to ask, oh, is this ever, equal to 2? That's the number you get exactly correct. So this should be that 2% number. Same again. Yeah, so that's the exact versus how often do you get, exactly 1? Well, let's do the same thing. 35% of the time we get exactly 1. Or 36, I should say, whatever. And how often do you get 0? Well, that should be the rest of the time. Right? Yeah, that is the rest of the time. This makes me a little concerned. What went wrong with the math here then? I feel like this number and this number. Interesting. Yeah, curious. A little bit odd there. Yeah, so that amount of time you just completely hosed. You get nothing correct. This amount of time you get exactly 1 correct. This amount of time you get exactly 2. This is sort of 1 or 2. Yeah, what is with my math here? Something change? Am I crazy? Am I double counting? Oh, well. It's not that I'm double counting, right? It's that there's twice as many predictions that you get to make here, right? If you get 2 right, oh, it's double the weight. So, I bet if you took this number, no, not that number, take this number, plus 2 times this number, I bet you get 4, 1, whatever, yep, 4, 0, 1, 1, 1. Right, because when you get one of those right, you get it all right. But this is a lie. In fact, this should be divided by 2. Right, because how many labels did I want to get correct? What is that many labels? So that's really, 20% accuracy baseline overall. And as I said earlier, oh yeah, that's kind of what I expect if I just always pick the same numbers. So that's kind of interesting. We have a baseline model now. That's good. That makes me happy. We can do this stupid thing up here too. I don't even train for 10x. Train for like 1. Right. Just do something. Crash. You must compile your model before. Yeah, whatever. Pretty sure I did compile the model file. SGG is not. Dang. Dang, damn it. One of these days. Alright, we have 1 minute remaining. That'll train, does a great job. Perfect. Yes, so now we've got new predictions. And, oh, it's on validation. Oh, okay, well, we can change that up here. Let me come back up here to our Adobe model. Predict these values for validation data. Even be a little bit harsher. For Heuristic, like, we designed it with the training data, so it ought to do better on that, but yeah, no, do that. There we go. Which can't handle a mix of multi-label indicator and continuous multi-output targets. What? VLab, pred? Oh, right, those are probabilities. That's a bad time. Let's do this then. Right. This was the 20%, now raised to 70%, but again, there's some probabilistic sense going on here. Here, you could set some threshold. You can say, I don't know, pred greater than 0.5. That should be fine. Yeah, and then, ooh, yeah, 29%. Recall. Oh, different preds. Dang it. I should get like pred 1, pred 2 kind of thing. Oh well. is what it is. We have completed our model today, and you can see even a dumb like linear regression type of thing can do a little better because, hey, certain pixels matter more than certain other pixels. It's not just the mean that is useful. All right, that is all I got for tonight. Thank you everyone who came out to see the show. I will post this to YouTube as always. So thank you, have a good night, and don't forget, stay safe in the data mines.